All right, clap once if you can hear my voice. Clap twice if you can hear my voice. All right, good morning or early on in the week. We're almost to winter break. Super exciting. Okay, let's talk about this warm-up. How do we feel with this warm-up? Yes, no, maybe so. All right, well, let's go over it. Right now we're in SQL land. Oh, look at that. Let's start with this one. This one was a bit easier than the other one. Oops, totally went the wrong way. And we go to description. All right. Can we see that? Or is that too small? All right, so we've got a table, world. It's a lot like the SQL Zoo one, it looks like. And we can see that we have a name, a continent, an area, a population. Maybe we also have a GDP. I don't know. This is kind of a weird visual display of this table. We can go, all right. And so we're looking for big countries. A country is big if the area is bigger than 3 million square kilometers or the population is more than 25 million. Who knows? I didn't say. I'm assuming people. Write a SQL solution to output big countries. So first thing we should be doing is looking at what we need, right? So we're always starting with the select statement. And so whatever we ask for in the select statement is what we're going to be getting back. Okay, so that's kind of like the first way to break down this. So we're going to say select, and what do we need? Yeah, right, name, population, and area. Okay, and then we have to figure out like where we're going to be getting this information from. So where are we getting it from? Yeah, the name of the table. So we're saying from world. So we're saying from world, I want these things. Yeah, bang.
Does capitalization matter?
No, I don't think so. For which thing? Any of it? You mean?
Yeah, any of it really.
But the standard is to like
Match.
to at least the standard seems to be to make these in all caps. Still works without it. Okay, so and then the next thing is, right? If I did this and I ran the code, I would get all of every name, population, area of every single thing from our table, right? So I want to do, I have to be a little bit more specific, right? Because we only want the large ones, okay? So this is kind of sounds like a good spot to put some sort of where, right? Hey, Reed, good morning. I would go where. So what's the rules? Winter?
Area is greater than 3 million.
Okay, so 1, 2, 3, 4, 5, 6. I think I'm okay in that. What's the other rule? And or okay.
Population greater than 5 million.
25 million. 5, 1, 2, 3, 4, 5, 6. Okay, let's run the code. This was our output. Seems. Is that what we want?
Yeah.
Yeah. Okay. A little hard to read from here, right? Let's submit and see if it just accepts it. Looks good. Mateo.
Mine wasn't working, but I just found world capitalized, non-capitalized, so the tables all capitalized. It doesn't matter.
Shouldn't matter.
Completely case insensitive. We capitalize in order to make it clear.
Yeah, it still works for me, Mateo. I think you might have a different zone. This one actually is from Sequels.
Well, yeah. Well, this is a different one. I want to reference.
Oh, yeah, sure. Yeah, we can do that. Let's go over the next one first, but then we can go over it. Sounds good. Okay. Any questions on how this one's working? Okay. Let's go to the next one. Where we do duplicate emails. How do I? This is like too big. There we go. Okay. So we're given SQL query. We want to find all the duplicate emails in a table named person. And that's pretty much all of the information they gave us. So, and I gave us some hints, but okay, so we want to select what? What are we trying to get back? We're trying to get back an email, so we got to start with that. So we say select email. Anything else we want back? No, right? Okay. And then from where? What's our table?
Person.
Excellent. And then, now what do we do? What do group by? What does that do? Trey, what's group by?
You want to just select a specific column?
Sort of. Does anybody else want to take a go at what group by? Jania?
So group by emails are gonna pull together emails that are the same.
Mm-hmm. Exactly. So group by is going to go inside of that column, and it's going to group things of likeness. So if I had a table, for example, for this table, if I say group by, I'm going to have two groups. I'm going to have A at B.com and C at D.com. I'm going to have two groups. It's going to split that up. That's what group by does. So I can do that here. And I'll say group by email. And let's run it and see what that actually looks like. Right, this is the output that we were expecting when we just group by. We have A at B.com and C at D.com because it's grouped the things of likeness within the column. David.
How different is that from order by?
Order by is a kind of a version of sorting in a sense that's going to have all of the entries still there, visible in the table. Group by is taking all of the things that are the same and pushing them into one new entry. That's a good question. Okay, so when we're doing group by, right, it seems like we would want to say like where count is and stuff, right? But you actually have to do having when you're doing group by. You have to use the word having. So we do that. We go having. So now we get to specify more specifically about our group. So having what? Count, yeah, having a count greater than one. What do we want to count? We want to count email, right? You got to pass in what specifically you want to count. Greater than, oops. So we're going to select the email from the person. We're grouping by that email, and we also want to make sure that the count of that email of that group is greater than 1. Now we'll try that. And a success. A great success.
Is it a parentheses?
Yes.
Semicolon letters.
It doesn't seem to matter for lead code. In real life, you want to use a semicolon. You get an error without the semicolon? You probably have an error. What's it say?
It just says function test that count.
Set up the same?
Yes.
Oh, I don't. Oh, I mean, no, this is very, like, you count. You could, get living around database. But for this specific database,
Right. So you wanted, what one did you want to go over?
Name.
Can you do it without loopback?
What?
Can you do it without loopback?
I don't know. I don't think I can.
Just say having count, email, written one.
That would have, did you try it?
you could just say where, count email is greater than one.
Okay.
So having is, I believe having is a keyword that's related to group by.
Okay.
So it's kind of the where of group by.
Yeah, but I don't know if you can do it.
But the system didn't accept these answers.
Try it, Winter. If,
Yeah.
which one, Jonathan?
Number 15.
I was using
Name.
where.
So you have to click on the sequence as well.
Oh, I don't think I want to get into that one. I think I know the one you're talking about. It's not like that relevant stuff. What you'll need. Yeah, I think it's going to confuse more people than what they really need. I'll definitely go over it with you individually, okay? Okay, so
Oh, I mean, it is.
Do the same thing, right? So let's say filter,
all right, so let's talk about binary search. Who's excited about binary search?
Oh, yeah.
Yeah, well, why? What's great about binary search? Yeah, right. Okay, Renat says it's all about the time, right? We got the time to learn it because we're going to be saving so much time in the long run. So it's a log n searching algorithm. This is only going to work with something that is sorted already. And well, and so like this goes back to like this real life example, right? So let's pretend, yeah, Trey.
I don't see it in the calendar. I just see a.
I will just post a link to it.
said it was log n.
Log n, yeah. Today is the 11th. Okay. Okay. All right, now it's gonna go. Okay, anyway, so let's think of a real life example where we might use binary search already. All right, so let's pretend I give you a huge phone book and I ask you to look up somebody's name, right? I ask you to look at my name in the phone book. Right, so there's ways you could do it, pretending we don't kind of already know the length of the alphabet, right? Because the alphabet kind of helps us. But if we didn't know anything, we could go like, okay, well, we could start on page 1. We could look, okay, my name's not there. Turn the page. Page 2, not there. Page 3, okay, not there. And we could just keep going, and eventually we would find it, right? We would find it in what time complexity? Yep, O of n, right? Because I'd be going all the way through the film book once. Okay? So, what if we didn't want to go that slow? That could be kind of slow. If we know that it's sorted, we can exploit that to our advantage. I could go into the very middle of the phone book, and I could check if my name is supposed to be earlier or after. And if it's earlier, I'd go, okay, and I'd take that section, and I'd break that in half. And I'd look. And I could keep doing this until I finally find my name.
How do you know it's early or late? You don't know already.
We know that it's sorted.
Oh,
It has to be sorted. That's a great question. Right? In order for this to work, it has to be sorted. If it does, if it's not sorted, yeah, you got to do it in N. You got to go all the way through it once. So a visualization of it here is are they telling us exactly what target runtime? Okay, so if we're searching for the value of 31, we'll go right into the middle, and we get 22, and we go, okay, is 22 less than or greater than 31? Well, less than. So between these two, we go halfway through that, which visually to me it should be this one, but whatever. We go 105, and we go, okay, is it less than or greater than? And now it's just between this and this, so we go back here, and we end up at 31. We go, okay, we found it, and we return the index. So when we're doing binary search, we're returning the index that the target's at. Not just a true or false. We're returning where it is so that we can find it. Okay. When something's not found, you typically return -1 because that's not an index in the array, I guess. Okay, so these are the steps, right? So with each round, this is a great like recursive function, but you technically don't have to write it recursively. But that's what we'll do today. And so the first step is to find that middle index. You want to check the element at the middle index and determine if it's smaller or greater than your current target. If it's smaller, you'll go to the left side and you'll recursively call it again, but just with that smaller array, just that first half of the array. So let's stop. Let's draw it a little bit. So if I have like 7, 8, 9, 10, 11, and I'm looking for the number 7. Right, so I'm looking for a 7. We're going to go to the very middle element, and we're going to say it's 9. We're going to compare 9 and 7. Smaller, bigger. Right. Very enthusiastic, but yeah, 7 is smaller than 9 still. So we're going to go, okay, great. We don't care about anything over here. So we're going to call our search again. So we call binary search on an array that's now 7, 8. I guess it's a 7 and 8. We don't really need to include 9. We've already checked 9, 7. And then we can grab the middle of this. So I guess it's going to be 7. I say 7 equals 7. Yeah. So we're going to return this index here. That's 0. But that's the mid index, right? 2 divided by length, array length, divided by 2, and 4. This is the mid-index. I guess that actually gives us back 1, so we would have done 8. My bad. 7's not 8. We're going to call it again. D-search. Then it's 1 divided by 2, 0, and we would eventually return. Yeah, David?
This is implemented in, what was the public or?
It's not implemented in either.
Was there some? That's not.
You did find a failure fix.
I don't know. I'm not going to make that comparison.
No, because we're not doing anything with the.
Yeah.
What about an array of strings?
An array of strings will work. A string, string. The order of strings is alphabetical, so that would still work. But we're typically using the numbers.
You pick if it's even, you pick either going to the most of it.
Yeah, you just gotta choose. So now this gets a little bit more interesting in a sense when we go the other way. So let's say we're looking for 11, right? And we say, okay, our mid-index is what? What's our mid-index? Let's see. 5 divided by 2 is 25. Okay. We're correct. Okay, so our mid-index our mid-index is actually 2, right? Okay. And we can look, is our array of 2, which is 9, less than or greater than 11? I say, well, less than. So now we got to take the right side. Okay, so if we call B search on the right side, it's going to be 10, 11, and 11. We got to keep passing that in. Now we got to find our mid-index now. Our mid-index again is going to be what number? That's going to be 1, right? So 2 divided by 2 is 1. That's that floor. So we have our new mid-index here, which is going to be 1. And that's at 11. We say, oh, okay, these are the same, right? What's the problem? Why is this not, like, what's wrong? What index is our target at? 1. It's 1 here, but where is it on the array we called it on?
5.
Right, it's 1, 2, 0, 1, 2, 3, 4. It's not actually 1 here. What are we going to do? Right, well, we had it from the previous call. So what we really want is to call our mid-index plus this before plus 1 to make up for the 0 thing here. So if I did 2 from here, right, 2 plus our 1 plus 1. This is to compensate 0th index. Then we get 4. Yeah,
The second one. Plus the mid.
just to make up for the 0 here.
5 and it was like 9, 10, 11. Just saying. That'd be 2 plus 1 plus 2.
No, still just the 1. We only would need to make up the 1, 0. But it depends also how you format everything else. If we had included our 9 here, then maybe we wouldn't have had to add that 1.
Is it always a 3-step process? Already a hat.
Yeah, so I mean, we have a base. We can have a base case, if we want. What's a good base case? Like with 1. What does that mean?
only one index in the
Sure, but does that mean we found it or didn't find it? So what's another possible?
empty array.
Yeah, empty array is for sure it's not in there, right? We could definitely set something up where we say, hey, if our array is empty, turn -1. And then we have to find the middle index. We have to compare the element at the middle index to the target. If that element is greater, we got to go to the left side. I'll be search on the left side. If the element is the same, we just return that index. If the element is smaller than our target, we got to do the search on the right side. So I'm going to write down a few steps for us, and then we're going to try to write our own. And then we'll go over. Okay? So let me pull up like a REPL. We will say, is this even bigger? That's probably a little too big. Okay, we'll say write a binary search function. I can select this out. You don't have to type the same thing as me. So first thing you want to do, right? So this takes in a sorted array and a target. Find base case when it's not in array. Right, we kind of talked about this one here. Middle index. Compare the middle element to the target. Decide if found smaller or larger. Call the search again. Don't forget to account for share with index. Okay, so spend like a good chunk of time here working on this, and I'll select this out. If you follow these steps, hopefully you'll get close. Okay, cool, let's go. Feel free to work with the person next to you.
I'll take it out. I'll be from. The zero is right now is the third index of our construction. 3, 4, 5. Right. But how do we use this? Oh, yeah.
Okay.
But if you have like a conceptual prior to right, so for 9 is already in there and operating, right, which is right 0, 1, 2, 3. We don't know whether or not it is. So I know that if not, it has to be right. So then I can call, I request all my information and this. Like it from this drive. So all that's left is to add to the 9
Let's see.
The middle index there is actually 2. That's the middle index element. So if it was array of 6 items. 6 divided by 2 is 3. His middle index is wrong. It should be 7. Okay. But
It's okay if you get
math differently. I feel like 7 and 6 are equivalent, you know.
That's why I'm asking. Like, yeah, differentiate in the middle when it's like.
Yeah, you just have to choose one.
Size.
Right. The way I think we'll write it is probably so it would be 7, but if somebody wrote it so it was 6, it's not like.
Because it just like it would be a group of 2 and it's not really different.
Exactly. Exactly. No problem.
Oh, yeah, so. Yeah, so I envision, like sort of 2 bases here. Right, because, there's only one base case, which is. Fundamentally, second thing now, right? Our rate is good, right? How else do we point is, we have to put another scenario if our array is just.
I see what you're saying. Well, that's what we have to. So since you know the time, how are you running?
I guess.
So now.
Call these section.
Yeah.
Or if it's not, then it's not. That's why. And then he started watching and it's right into himself. It turns into smaller. Oh.
Okay, so binary search is there's ways of searching data. Where like so normally when you get like in the other ways that we learned about search, right? We start from the beginning. Right? It's like global then operation. Right? Because it's sort of the end of the year, right? Potentially you'll have to do every single right? So binary search does. Okay. Big array is sort now I'm looking for a specific thing, right? Then what I can do is I can key into the middle of my set of data. And if my thing is bigger than that, I adjust it to the right side. And if my thing is smaller than that, I adjust it to the left side. Right? So that's fundamentally what we're doing here, right? We're picking the middle index, right? If our array is odd, then the index is weird. Smack that middle. Our array is even just not many. Two middle. See what I mean? And then we're saying, so hey, I keyed into that index. Is my target bigger or smaller than that? Okay, bigger than that. Okay, then I'm going to perform that same operation. Just
Not together.
and then I perform it on my right, on the right hand side, and you set my 15 here at 9. So my middle index is 9. Oh shit. There it is. Right. So I only have to perform like 2 operations basically, right? Versus right. So when you have a sorted set of data, it's a significantly more efficient. Right. Well, it is binary in a certain way, right? Because you're dividing into 2 each time, right? You're dividing the set into 2 each time. That's why it's called binary, because you keep dividing it. So as long as that kind of broader concept is like okay for you right now, then the syntax of the code works all over that. But sort of want you to, we just sort of want you to initially just kind of give it a shot based on that basic conceptual, right? Yeah. 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 It's pretty sweet. It's the most efficient way to know how to find something in a set of data right now. And it's kind of weird to say that. It's like crazy super nerds do that thing. Like crazy super nerds. No, it's the most efficient way to know. This is it. This is it. There's like tiny micro optimizations that can happen when data in trees instead of whole lines, but basically it's the same pattern. It is just trying to like bigger on right. Volume.
You do need this. If you want to do the it's more very we try it all the time. I didn't get that.
I'm just hovering because I heard that monumental sigh. It's like I feel like I should put that in my calendar.
Well, my first one is like the rate of like,
Did you get one, Alex?
I'll just do that. I mean, I don't think that's the rate.
Oh,
So as an example, over steps, right? Your request is 79, we'll enter 9, so it is 5, it is 7, 8, 9, it is 8, 9.
Oh, yeah, out here.
So, I
Left side, right side.
You have to like.
So this is
Like a meeting, They don't have 5 to 1.
our recursive stack track of yeah, so kind of what we're doing here. So let's do a bit more. We're looking for 9 in that right? So here our middle index is 4, right? And then so we do so effectively what we're doing is the same 4 plus and then we call here our middle index is 1, right? So we do 4 plus 1 plus 4 actually right? Because we are going to 3, 4, 6. Yeah, because these are we wrote that, right? They're not technically zero. 4 plus 2 and just go into 1 and then 9 plus 1, right? So we get 7. Oh, plus 1. Plus 1, because this right is right. So it's like we are explicitly keeping track of our middle indices because we're adding. Middle index. So that's blah blah blah. So
We're here, we have like.
Yeah. What's up?
All that on small. First of all,
Yeah, right. It's that basically. So you're doing. So first of all, right, binary search assumes that you're arrays. Right. So it will work. Second of all, if the array on scripting is 0, we need to add a secondary
Sorry, did anyone in your class
I don't know, someone just gave it to Shopkins. Is mine yours? Okay.
That be something.
It's got Oh, okay.
Yeah, so there needs to be another clause onto the space case because, if you think about it, right, if we do a recursive call on, well, actually, no, that should be fine. I think the problem is just that you're right. So if it kept trying to, oh, you should also say instead of returning or taking, say return to because you returning.
You can just define them as this.
But because there's only always calling. Sorry. Because we're only calling when the number is greater than or less than or nil index. But if you're doing mix greater than or nil index, then that means our number is
matching target.
so if you rate out equals 0, when you're free all is right? Then that means it's exist, right? If our target was 10, right? Then I would say, okay, it's greater than 5, it's greater than 7, it's greater than 8, it's greater than 9. So then I would evaluate it in 3, right? And that would be, it's straightforward. Right? So what we're doing is we are constantly performing that function on two. We're constantly performing this function on two subsections of this array, right? But we're not just performing it, right? We're performing it based on a very specific function that'll be related to it. And that given the thing is less than or shitting about it. So if I get some, it runs. Runs away from it.
It's feeling every time.
Congratulations, it's not in there. Right? So I don't think that we're ever going to get ourselves into a situation where we raise land at 0 when we call it on there and our target is 0. Right? So I think that your base case is line is essentially one of the opening. I mean, you know,
Your ending condition line.
She give us. She give us. I don't know.
Voice coming out full of confidence. What's up? Yes.
I don't understand what you meant by that. I didn't get like that.
Right. Okay. So, great question. So when I have an array of 7, 8, 9, 10, 11, right? Here. When I'm gonna write 7, 8, 9, 10, 11, right, and what I'm looking for is 11, my middle index is 9, right? And that is the second index of my array, right? It's index 2, right? Now here's the thing. If I was looking for 10, right, I would do a binary search on this right side, right? I would find 10 right here, right? And I would potentially add 0 to this index, right? Because if we just look at this subarray, 10 is the 0th index of that subarray, right? So I potentially evaluate 2 plus 0 here, which wouldn't be right. It would give us the index of 9 in the array. Does that make sense? Because this smaller array starts at 0 too. The thing is, right? Because this smaller array, I did turn it off because it's
It's alright, I just have to stop the live stream.
the thing. Oh, sorry. The thing is, right?